All right, let's finish up law of sines and talk about this situation with side-side angle and what could possibly happen with side-side angle. All right, the problem when you're given the information of side-side angle is it's possible that your information will generate no solution. In other words, it won't the side lengths that you're given won't create a triangle, or it's impossible to create a triangle with them. One solution, which means it creates one triangle, or two possible triangles. Let me show you what I mean. So if I give you a side and I give you another side, it's over here, okay, so leave that like that. And then I tell you what this angle is. I tell you this angle theta here, right? So you know this side, call it, I don't know, call this side A, I guess. You know angle B, maybe, and you know side B. Okay. If the information you're given here for side B is as I've sketched it here, then this side is too short to create a triangle because no matter what angle you put this angle up here at, this would be angle C, I guess. But no matter what angle you have for angle C, this side is not long enough to make a triangle, so that would be a no solution situation. If the side length is very long, then it will come down and it will make one triangle. Okay, but if the side length is a certain it's actually in between two values. We're not going to get into the details of it too much, but it could come down and make a triangle here and also a triangle here. In other words, you would have this weird sort of obtuse triangle here, right? And then you would have this triangle here as possibilities, and you don't know which one you have. So in that situation, we would find both of them. Okay, now you're not going to we're not going to get into the nitty-gritty of how you determine this geometrically or whatever each time. I've just given you a chart here to kind of simplify things. Okay, if you go on and take pre-calc and trigonometry, they will tell you, then you will kind of dig into this a little bit deeper and do more analysis and kind of determining what's going on here. All right, but for our purposes, we're going to follow the chart. Okay, if we're given an acute angle, then these are the three possibilities. If we're given an obtuse angle, then these are the three possibilities here. Okay, so find angle B. Given this information, so what I always do is I always sketch the information I've given first. So I'm given angle of 115 degrees. So 115 degrees is, if I let this be the kind of the one side, 115 looks like this. Okay, that's angle A. It's 115 degrees. Okay, I'll make this a side here in a second if I can. Okay, side A is 20 degrees. Sorry, it's 20. So side A is 20, and B is 11. Okay, so this has to be 11 here, and 20 is over here. Okay, so I can see visually that I'm going to get a triangle here. Now, suppose, like I said, you don't want to mess with the kind of thinking about this geometrically. You don't have to. This angle that we're given is obtuse, which means it's greater than 90. So I check, and I see that the calculator will either throw an error if there's no solution, or the angles will add to greater than 180. If there is a solution, then there's only one, and so you can just solve it. So the nice thing with an obtuse angle is you just go about solving that triangle using the law of sines, and if it throws an error in your calculator or the angles add up to more than 180, it's no solution. So let's do that. I've got side A and angle A. You remember that the law of sines is sine of A over little a is equal to sine of B over little b. All right, right there. Okay, and so let's set up the ratio. So I've got sine of 115 over 20. That's equal to sine of B over 11 times 11 times 11. All right, and so that simplifies to 1 on the right. Over here, I've got 11 times sine of 115 over 20. So 11 times sine of 115 divided by 20. And then remember, that's sine of B. So sine of B is equal to 0.498, whatever. I'm just going to take the inverse sine of both sides. So inverse sine of my answer, and that will kick out 29.9 degrees. So B is 29.9 degrees. Okay. All right, next one. Find angle B. And this one I have an acute angle here, okay? And this is my opposite side because angle A and side A have to be opposite, so this is my opposite side. This is my adjacent side. Okay, so I'm on the acute line because the angle is less than 90. I have an opposite side that is less than the adjacent side. Okay, so if opposite side is less than the adjacent side, that's going to give me two solutions. And we want to figure out what angle B is. Okay. And all we're trying to do is find this angle. So let's take and set this up. So I've got sine of 51 over 3.5 is equal to sine of B over 5. Now, this is a two triangle or two solution situation, but you should always run it through first, see if your calculator throws an error when in this first step. So I'm just going to show you everything in the calculator instead of writing it all out. I'm just going to take 5, so I'll times both sides by 5, right? And so I will get 5 times the sine of 51 divided by 3.5, and then I need to take the inverse sine of that because I get this, so I get sine of B is equal to 1.11. Then I'm going to take the inverse sine, and I get an error. Okay, so that means that there's no solution. So always take that first step of, if you get the two triangle situation, take that first step of trying to find that first angle. And if you get an error, then you're done. There's no solution. All right, so let's solve the triangle here. I got opposite side is 13. I have adjacent side is 16, so that's adjacent. And so I've got opposite is less than adjacent. Okay, so that's possibly this two solution situation. Could also be no solution, but I left a lot of space over here, so let's see what happens. So I'm going to go find the angle here, sine B, so sine of B over B is 16. That's equal to sine of 40 over A, which is 13. I'll times both sides by 16. So in my calculator, I'm going to have 16 times sine 40 divided by 13, and then I'm going to have to do the inverse sine of that. There's the inverse sine of my answer, and I get 52.3 degrees. So B is 52.3 degrees. Okay. In fact, let's make a little list of everything that we're finding here. So we're going to try and find the we're solving the triangle, right? So I need side or angle B, I need side C, and then I need angle C. Okay. And so I'm going to fill in the box here. Okay. So then let's go find angle C. Now that I know angle B, I can figure out what angle C is, right? So angle C. Wish I had organized this a little bit smarter. Let's see. So angle C is equal to 180. Sorry, angle C is equal to 180 minus 40 minus 52.3. Okay, so that gives you 87.7. So that's 87.7 degrees. Now I just got to find side C, and because I know angle C is 87.7, I can just set up the law of cosine or law of sines again to find little c. So little c over sine of 87.7 is equal to let's see, I'll just use a's again because that's easy. So 13 over sine of 40. In my calculator then, I'm going to times those sides by sine of 87. So I'll have 13 times sine 87.7 divided by sine of 40. That's 20.2. All right. And so that gives me everything I need for that first triangle. Now, this is the important thing. If you know that there's two triangles, the very first thing you do to find the second triangle, or the second solution, think of it like that, I guess, is you take whatever that first angle was that you found. So it was angle B, right? And you take 180 minus that. So over here, we're going to go find, let's call these, actually, let's see if we use the, I'm going to keep the notation the same here. Never mind. I have to mark up this. Okay, so I'm just going to use C and prime. Okay, so if I want the second triangle, it's going to be B prime, so angle B prime, little c prime, and angle C prime, okay? So we'll go fill those in as we get them, all right? B prime is going to be equal to 180 minus B. And that's always going to be 180 minus the first angle that you found. So that's 180 minus 52.3. And 180 minus 52.3 is 127.7. So this is 127.7 degrees. Now, angle C prime is going to be 180 minus 127.7 minus the other angle you've got, 40, which is angle A. Okay? So then, take 180 minus 127.7 minus 40, and you get 12.3 degrees. Little c prime, we're going to have to actually solve for that. So little c prime over sine of c prime is 12.3. So sine of 12.3 is equal to, and we'll just use the a's again. So 13 over sine of 40. All right, and then you can take 13 times sine 12.3 divided by sine of 40. Just solving this equation here, and I get 4.3. Okay, and that's it. So there's my two solutions right here and over here. Okay, if that was confusing, you might want to watch back through it again. There's very few examples like this, maybe only one that shows up on the quiz. And even if you miss that there's a second triangle, you can get that you can still get the first solution. So if you find it completely radically confusing, it's it's not going to torpedo your grade or anything. The last thing is these area formulas that are built from the law of sines, okay? And they're very straightforward in that they all look the same. And so basically if you have an angle and the two sides that make it up, so in other words angle A and side B here and side C here, those are the sides of the angles. If you have that, then these will find the area of the triangle, okay? So in this one, I check, I have an angle and then the sides that surround it, so I can use this first equation here. And so the area in this example will be 1/2 times 11 times 7 times the sine of 120, and that would give you the area of the triangle. So 0.5 times 11 times 7 times sine of 120, and that's 33.3 is the area. Okay, and that's it for the law of sines.